Hello, YouTube. We're starting in about 2 minutes.
For those who are not in Zoom's call, please join the Zoom call from the Google. There is a link in the chat. So 2 more minutes, yeah, or 1 more minute.
Mika, can you mute yourself in Zoom?
Okay, everybody, let's get started for today. So we have an open space with Robot Framework, and today we are trying new thing. So we are streaming to YouTube, and this is being recorded, and it will be available in YouTube for infinitely. First of all, my name is Miikka Solmela. I'm the Executive Director of the Robot Framework Foundation. And it's my pleasure today to have here Ismo Aro talking about energy consumption testing. Ismo Aro is a former chairman of the board from the Robot Framework Foundation, and he's also the CTO of Northcode. And basically, Ismo's thing is very cool. But before jumping in, I just want to quickly say for those who have not yet purchased a ticket or otherwise gotten a ticket for RoboCon online next week, please join us. If you do need a discount, you can contact me directly. I can give you a nice 15% discount on the tickets. It will be interactive experience on Cattertown, great talks. You have community time there as well, some after parties in beer, so in a virtual bar and so forth. And our host is Joe Calantanio. He will be really good with the Q&As, and everything will run super smoothly with him. So it will be a very good experience. So without further ado, I would now like to give the floor to Ismo Aro. So go ahead.
Hello, everyone, and thank you, Mika, for the introduction. So, like I said, my name is Ismo Aro, and I'm working at a CTO company called Northcode, and today we are going to talk about energy consumption testing with Robot Framework. And like the old saying goes, if you can't measure it, you cannot improve it, and that's the point here in this presentation. So if you were in the RoboCon 2 weeks ago, and this is basically the same presentation here, a little bit more because I have a little bit more time and hopefully a little bit less hassle that I had there. But anyway, the main point here is that digital services have already a greater carbon footprint than aviation does. And that was a bit shocking when I first heard it, but then it makes pretty much sense. And digital services are not going away, and they shouldn't go away, because that's a develop, and that's it. And the time of this generative AI, we are creating this digital service even faster. So then we need to again consider about the carbon footprint, that how we can reduce that one. So and of course, digital services also creating a carbon handprint. So we are reducing carbon footprint with the digital services. Example that we are automating things what people usually do, they would be more effective and efficient. And also we are creating green technology with the digital services. So digital services are good, carbon footprint is bad. Here's an example about the development cycle in car manufacturers. And in the left-hand side, we have a Ford Mustang 69 Mach 1. And during that time, how your car manufacturing in the United States did that, if they wanted to have more performing car, more direct way, and how they thought it that we need just bigger engine, so add more stroke. And the end was this 7 liters, very beautiful machine, produced highly 335 horsepower. And way car manufacturers in the United States are thinking these days, and Ford is thinking these days, that they have changed the whole thing. If you think about the fundamentals of the car, so it's not anymore petrol car, so it's a fully electric, and it's more performing even what this big, huge engine cars were, this muscle car in the 60s, late 60s in this case. And if we think about the Moore's law says that every second year we are getting double amount of transistor in our chips, which basically means that we get more memory, more computing power, and that's increasing. So we don't need to care about our application code or then programming languages, what we are using, application servers, and so on, because there's always be a more power to run those. But this is now, maybe we should also change how we are thinking about this thing. Maybe we should make our products less energy consuming things. Where the carbon footprint comes, of course, manufacturing these devices, servers, network gear, and also end devices like computers, mobile phones, etc. And that is consuming resources and energy. And then those devices, when we are using them, they are, of course, using power, so electricity, and that we need to create. And already mentioned the impact areas of backend, transmission, and also end user devices. And what we can do about it, one thing is that we should move more towards cloud native, and the basic thing there, because we are sharing those resources with the different companies, with the different projects, the same resources. So we are not anymore dedicating one server for one thing, but we are sharing these resources. Of course, always cloud is also computer. We need to remember that, but we can allocate those more easily. Avoid over provisioning. This is things what happening these days, that we are not allocating the resources for the peak hour, and then rest of the time it's idle. Basic idea, the basic thing here might be that you have a Kubernetes server where it's a on-demand like allocation of the nodes. So when there's a rush hours, you have more nodes, and when there's not that much traffic, you are scaling it down for the smaller amount of nodes. Then actually these 2 second things is something that I'm going to show in this demo. So choose better application servers. So you can check there that is this better than other. Also operating systems matters. Actually the hardware also matters, these kind of things. And then you can optimize your own application. So it might be that you have a different kind of way of doing things you are getting the same end result, same feature, but you can have a different way to do it. Or then you can have a library do the same thing, but another one is consuming less energy than the other one. And now about the demo. So here, what we have here, we have a computer. It is my computer here. Then we have a test tool. And this is now, by the way, concept. So this is a concept how we are doing with the test setup, but you can also have you don't need to have exactly the same test tool. And way we are doing it here, you don't need to have it, but the method works also with the other approaches. But now what we are using here, we have a test tool, and this test tool is called a robot framework. Then we have a Frontend. We have a 2 version of backend. So there is Node.js, and then there is a Tomcat version, so Java version. And front end is a React. And so this is basically full stack web application. Then we have an energy consumption meter. It's just a listener in a robot framework. So we are using browser library to execute these web test cases. And then we have an energy consumption, which is this one is, like I said, it's a listener in robot framework. So you can easily just plug it in. And what is measuring the energy consumption meter? It's measuring the CPU usage. Pretty simple, just checking that, okay, how much CPU is used by the process, like a front-end process. In that case, it's a browser, and a backend process, which is Node.js or Java. How much consumes memory, and how much the network traffic is between the front-end and backend. And these are transformed to watt seconds. So we are getting these values, we are monitoring these values during the test execution. Then we are getting raw values out, like percentage of CPU usage, how much memory has been used during the text execution, and how much there was data between the front end and back end. Yeah, and then transport it to watt seconds. Like I said, this is an example. You can also have other tools using it, but this is really straightforward way to do it, that making this energy consumption measuring. All right, so the demo itself. So what we have here.
Ismo, do you want to have questions in between if people have questions?
Yes.
Just like audio questions?
Yeah,
or
yeah,
sure.
Yeah,
okay.
Audio questions and chats are.
So if you have any questions, feel free to just answer your question and interrupt Ismo. And if you want to know how it works internally or stuff like that, just be aware that this is recorded and will be publicly available. Okay, go ahead. Thank you, Ismo.
You're welcome. Yeah, and I don't know, do you have this kind of hand thing that you can raise your hand in this Zoom meeting? Okay, so just raise your hand and I'll stop there, and then we can have a discussion there. But anyway, so what we have here, we have really simple web application. 1 second. I want to move this Zoom thing somewhere else, like this. So this is calculating prime numbers, and it has been implemented 2 different ways. So when we're asking prime number, the first one, the front end asking 2000 first prime numbers. So it's starting from the 1, then next one is 3, 5, 7, etc., etc. And it's giving 2000 those prime numbers with the one fetch. Actually, we can here, yes, can actually check it from the network. So click here, fun fetch, and sorry, it's not on. Okay, let's start it. Now it's on. So one fetch, and it gets all, and it's print here all first 2000 prime numbers. Let's clear it. And next one that it's asking these prime numbers 1 by 1. So frontend is sending prime number and asking next prime number. It's sending to the backend. Backend is calculate next prime number and then sending back to the frontend. Basically, the functionality is same, but it does a little bit more differently, and it's taking a little bit more time. All right, got it? Hopefully, yes. So we have two test cases with this really beautiful test automation tool called Robot Framework. It is testing the same functionality with these two different versions. And you can just we can execute it like this.
Pääkasti. Nyt pitää viedä seuraavat liiketkin alas ja hakea, niin voidaanko täyttää tämä kasti?
Tatu, laitatko muteille?
No, it wasn't Tatu, it was Pekka.
Pekka. Pekka latko muteille. All right, so now we execute the test case. This is really wonderful during this, like we are doing remotely stuff. But anyway, so we executed and these were results. So nothing really extra here. Now we were talking about this listener. So adding listener here. Sorry, it's energy meter. So just adding listener, that's it, nothing else. Now we execute it. Now it starts measuring these three things. Damn it. So my bad again. So I have also this. So let's do it again. So listener, executing this listener. With this listener, the same test case. And as you can see here, this was surprise. The later one to consume much more energy. And the first one, okay, even the meter node didn't do almost anything. It was so fast that it might be that because it's measuring 10 times a second, it might be that it didn't even get the peak there. So nothing happened there basically. The Chrome took something and there's a little bit network consumption. But the later one, when we are creating a traffic between the front end and backend, this starts to be a pretty big number. So here we have a 528 watt seconds and backend 759. And this is happening not because of the calculation, but like Node.js needs to start to work when there's an API calls this much. So this is start to consume the CPU. And also there's some network consumption here because there's huge amount of more traffic between now the front end and back end. All right. So what we are measuring now here, in this case, it was that we measured between two different way of implementing the same thing with the same application server. Something what we can do with this thing. So this one was so that one was with the Node.js, and this one is Tomcat and Java. So I just add variable server Tomcat because it's just changing the URL, executing the same test case. And actually, this is pretty interesting, but it's almost the same. I have different setup with a different computer. Actually, usually the Node.js is less consuming, but it might be that because of this my computer setup, because this is now also and it might be also the Node.js version and also Java version and the Tomcat version. So if you can think about this, you can check also that if you have how I see that you should use this one is that you are putting continuous integrations, testing it like constantly, like it can be in the smoke test set. Then you get the trend. It might be that you want to change like a Node.js version. Then you can see that, okay, did it make an effect also in the energy consumption? What else you can do there? You are changing your code, you see the trend, is it going up or down? So this is basically new way of doing this non-functional testing. And this is something that if you already have this set up, it's really easy to plug it in there. All right. Here are the links to the article about energy consumption testing and GitHub repository where this example code is. Please give it a spin. It should work with the OS X, Windows, and Linux. Any questions? There's something in the chat. I'm muted.
How accurate that measurements are?
That's a good question. This is something that they cannot be exact. It's more like giving a direction, because there is if you would measure it from the plug, so measuring directly from the how much the machine is consuming energy, that would be more accurate. So this is taking from the CPU and CPU memory, and of course, because there is a operating system top of that, everything else, it's not that accurate, but it's giving pretty much the same result when you execute it again and again. So in that sense, it's actually at least start to give a direction, and it gives like a consistent answers there. And this is something that I would really invite something or others also try it out, that how like because anyway the idea should be that you are getting a direction, not like it might be that not exact number are not that important, because this is pretty straightforward approach to the problem.
A question.
Yes.
How or have you seen some other ways to trying to measure the energy consumption, or is this the first poke? Kind of, I'm just curious. Like,
yeah,
this is a huge energy amount. So, are there some ready-made solution already in the market?
Yeah, there are, but there's also this kind of, but they are more like a hardware based. So they are really measuring really like how much electricity is consumed. They are like in the Raspberry Pi version, when you are applying the software in that one, and then it's measuring really from the hard, really like how much it has consumed energy. But that all again something that you need to buy a hardware. You need to buy like a tester. So idea for this is that you don't need anything. You are using already the stuff what you have and getting the numbers out there.
Thanks. A follow-up. Do you
Yes.
see it is at use at large scale, or kind of like how would you approach it if we have a regulatory need to measure energy consumption? So how would you approach it? Is this a first kind of a pivotal step towards measuring everything, or is it just kind of like a nice to know information, or kind of like which direction it should go?
Yeah, my opinion that this should be that we should start to like okay, that's also now recorded that Teemu is starting to play Fallout 76. Okay, so my opinion that this is again something that this should be tried more like with the bigger scale, but at the moment it seems, and everything what we have done, that this is giving a right kind of answers. So this should be part of the continuous integration system. So you are regularly executing these test cases. It might be part of the regular test execution. Then you start to get trend. You could put it like a Elasticsearch or some other database, and then you start to use a Grafana or something like that you are like starting to draw it. Then you can see different components, that how much they are consuming it during the development, and then also what kind of, if you are changing those components, what kind of effects they have. So my opinion, there should be one part of the, when you have a functional testing, you have a performance testing, security testing, stuff like that. It should be a one part of also this kind of non-functional like a testing, the one part of the testing. This is my opinion. At least we should try it, put it that way.
I have at least one more question, but if somebody else wants to shoot in the middle, go ahead.
I would have one question. It's more when you're measuring front end, back end, you're telling the listener the process IDs, or do you have to hook kind of some code into these front end and back end things?
No, it's just a PS util, and it's measuring something
Okay.
that if you are using a node, it's checking that, okay, before the test execution start, what node process we have.
Yeah.
Okay, actually, node is something, it's okay, from the browser part, it's checking that what browser you have. You are using Chrome here. If you have those browsers, what you have at the moment open, it's checking everything when you start the test execution and start to measure those. So you don't need to do anything for the like a code itself. It just starts measuring those processes.
So it's kind of checking the delta processes from what are running before the test execution, and then plus new processes that are spinned up during the test execution and closed afterwards as well, or? Yes.
So it's checking that it's only measuring those ones which are related to test execution.
And actually, but the backend, for example, can be on a different machine, and it can be I don't know. You may have no direct connection. Like here, you have everything locally.
Yes.
And you are also, but the backend is anyway. It started before the test execution, right?
Yeah. And it's something that's what you know, that okay, started the node, then you know, okay, this is the node there, and this is now in this case it's a node index, so you can check from there exactly the process there. But then this another question. Okay, we are executing everything in the same machine. Of course, that's most straightforward, but nothing can say that you can put also to the target, to the backend machine, that you are taking an SSA connection or whatever there and start to measure it there. Or then you have a own small piece of like a software which is doing the measurements, and then you are connecting and like talking with these, like a test execution machine, and also backend can discuss them and sending these measurements back. And there's also what we haven't yet like a dig in, that if you have a Kubernetes, then you can use a kubectl and checking from the node level the consumption, how much they are consumed. But anyway,
does Kubernetes and Docker, is there no way to get kind of CPU time for a specific container or so?
Yeah, you can. Okay. But then it's measuring the whole container. So the question
the container is, I mean, the container has basically no idle consumption. I mean, your computer has idle consumption, but the container itself is just like it's just a box where you can run processes. So if there's no process running in the container, it's really zero. But once you start something in the container, and even robot starting in the container cost money. So like the Python process, is this also included in your measurement? The robot process?
No, in this one, no, because we are not interested about that part. We are only interested about the front and the back end, like the suit stuff. And this is something, and this is actually pretty interesting, because now it's a Python, and that's consuming, of course, energy. But one way to do it, that you can write this part with the C or C++, more like an effective coding language. Because we were talking about one of the Finnish clients who are making this kind of IoT devices, so really small devices, and they have RTOS in the machine, and there's a really limited amount of space, so you cannot execute Python there. But then you can also write this, because like I said, it's a concept, so writing it with the C or C++, I see no problem there. Of course, it needs code, but the method itself should work there. And then you can have really lightweight, like this measurement part. That would be actually pretty cool also.
There is a question in the chat. Hey, someday will it be possible for this to test other types of apps, such as static binaries used for monitoring systems events?
You can everything. If it's a process in this method now, if it's a process in your computer, then you can measure it. It doesn't matter which process it is. It can
And
be.
Again, regarding the process ID, can I tell that thing, okay, the following process ID is the backend, please start measuring it?
Why not? If you know it, and it might, because now it's kind of made a little bit stupid. So we are just saying that, okay, now measure the node with the index like as a parameter.
Okay, but now in the current GitHub repository, in the current listener, it's not like that. I can give it a configuration like monitor the list of following process IDs, something like this.
Not yet, but it's something that it's really, that's just piece of code, my opinion.
Yeah. For example, in my environment, we would have a server, but the server is made out of 3 Java processes, and they are all just Java, and the frontend is also Java process. So, but I know the process IDs of that, and when I start the process, I get a new process ID, even if I do it by the automation, or if it's running before, I know it beforehand. So I could actually tell like.
Yeah. Then because it's anyway, this is like digging out the process ID, the PS util.
Yeah.
So this is a pretty more straightforward. Just get the process ID, then it's just measure it. Yeah, that's really doable.
Right.
No problem there.
I also had an additional question. So, have you actually tested how the consumption differs from if you use these hardware devices? So how close it is to those measurements?
You mean the one what I mentioned before, that there's
a power meter? Yeah.
That would be. Yeah, we haven't. That's a.
That would be interesting to get a baseline kind of.
Yeah, and that can also be, if there's a difference, then you can start to calibrate like this one, because this is anyway giving a pretty good, like a solid numbers, that if you execute again and again and again, it's giving, there's not that big difference between the execution. And of course, if you have a like a CI/CD system where you basically might have that you have a one dedicated environment for your test execution, it should be more like accurate. But then measuring against, that would be really cool.
Yeah,
maybe we should try it out.
So technically, if you take a power meter, you will have a huge overhead just by the CPU running, and of course, if you have a process that is really doing calculations, you consume more power, because the calculation intensity on a CPU needs some power. But you would need a super clean environment. For example, in the current situation, we have Zoom, then I have a web page open. All these things are alternating up and down. Then you have a system that is just for a second checking, hey, is there any update? And just going with one core to 100% and going down. Or the window manager or the garbage collector of any Java process kicks in, and you just go up and down. So I think would be really hard to have such isolated environment that has basically no background processes to use for calibration. Maybe even it would be better to just call it like you have 700 bananas than having 700 watt hours or watt seconds. I mean, a theoretical unit could also be just used.
Yeah. That was also one of the idea, that maybe, but watt second is something that it's kind of understandable, even it's not like a really, you cannot say is it really accurate. But anyway,
you can convert banana to watt. That's definitely possible. That it has an energy stored in it. So maybe using bananas has the same jitter or tolerance than.
Actually, banana have a huge amount of energy.
Yeah, I mean it could be pieces of bananas then maybe.
Yeah, it should be really small bits of bananas if you're going to the relativity of relative theory. Let's not go there. it's like a
Could just
okay.
check
Okay,
I'm just googling now what is the energy amount of a banana.
You can just calculate because it's a E and
Yeah, sure.
M. Yeah.
Maybe
Maybe we
questions?
should. This would be a beautiful discussion in peer-peer with a couple of peers.
Speaking of beer, we will have a pre-conference beer gathering, I think, on Tuesday evening. So for those who are present and want to join us at beer in Gathertown. If you don't have a Robocon ticket, buy one. Or buy 10, get one free.
That was a paid commercial.
What?
No, that's okay. Yeah, but anyway, about this whole thing. So like I said, it's a really straightforward approach to this problem. And it's something that, and I like straightforward approaches. So I would love to see this out wild, that people start to use it, and let's see what kind of like outcomes we would have there. And then, at least so far what we have investigated it shows that it gives like a good solid numbers. So at the moment it sees that it's going to pay off. And in the future that people are using this part of or something similar approach as part of the like a test automation, test executions.
So 100-gram banana are 370,000 watt seconds.
How much?
372,000 is 100 gram of banana. So basically 1 gram of banana would just be 3,000 watt seconds. And then you can start recalculating, like we had here now, then what was it, like 700? So let's say 100 milligram banana.
Yeah. Banana scales, like it was back in the future, what it put in the fusion reaction. Yeah. Okay.
Sidetracking right now.
Yeah. Any other questions related to this thing?
Have you ever applied this to somewhere in real life?
Not yet.
And actually.
And this is why I'm here, that if somebody would love to try it, please try it, and let's see what kind of measurements we have. And of course, we have discussion with the different clients who has been interesting about this and start to have a pilots, but we don't have a real yet anything from the real environment. So this is like I said, this is a concept yet still, but like I said, the concept is showing really promising results.
Yeah, I would have been interested to hear about the challenges in real life scenarios.
Yeah. Hopefully this is something that when there's going to be next Robocon, I will tell about those challenges. And of course the victories also. But let's see.
Was there a question from Guido?
Yeah. You already mentioned Kubernetes and possibly using kubectl. But has that already been implemented, or is that something?
No. This is something that we have only discussed, but it's not, again, because it's a Python code, and there's probably, I haven't checked, but there's a Python libraries for kubectl. It shouldn't be that big thing to do it there. So
there's even a robot framework library for it.
So it shouldn't be a big thing to implement that part.
Yeah, so sounds interesting. Although in my current working environment, we have we use Kubernetes as a where we run our tests, but the application itself doesn't run in Kubernetes at the moment.
Okay.
But it looks interesting because we're moving that way to also monitor this. Hence my question.
Yeah. And I think because Yeah, at the moment the demo is just working in one machine, but this that it more like having that way that it's distributed and also that it's containered and also orchestrated by the Kubernetes. That would be something to look into, and that's probably something what need to be implemented pretty soon, because usually nowadays, yeah, pretty much stuff is run in the Kubernetes and containers.
Yeah, more and more.
But that's not 100-gram banana is 89 kilocalories, but it's consumed by the human being, right?
Yeah, but of course you cannot put a banana into a computer, but it's energy.
Yeah, but it holds more energy if you are checking to the relativity of the relativity theory.
I mean, if you want to do that on a bike, you even have losses on the creation of the energy and then on the transfer system and stuff like that. But we are just talking about energy. I mean, we are also not talking about the AC/DC conversion of your computer and blah blah blah. So
yeah.
We could also have other strange units like foot-pound or so. It's not that weird like bananas, but still weird.
Yeah. Any other questions?
Okay, it seems like Ismo has done a good job, so everything was answered. So thank you, Ismo, for being here.
You.
And thank you for the presentation. I would now release Ismo from his duty and open discussion on any topics that you feel fit to discuss, mostly related to robot framework, but can be something else as well. So anybody wants to discuss anything, topics to bring up?
How is life after the on-site RoboCon?